More classification metrics. So let's go beyond just a number for accuracy of a machine learning model and look deeper into its performance. A confusion matrix is a good tool for this purpose. A confusion matrix is a presentation of the accuracy of a model and the errors that it would make for problems with two or more classes. You have already seen the confusion matrix. This is the confusion matrix that is going to tell us the number of true negative, false positive, false negative, and true positive. True negative and true positive are where we actually have made the correct or true prediction, and false positive and false negatives are our mistake or error, which is false positive is the alpha type 1 error and false negative is type 2 error. We can actually use or build a confusion matrix for more than two classes. So in the confusion matrix above, we only have two classes. We have positive and negative. But we can develop actually a confusion matrix for more than two classes. Suppose that we have 27 cats and dogs and rabbits. So we have 27 animals. Some of them are cats, some of them are dogs, and some of them are rabbits. Based on this, we want to make a prediction here. So we have three classes, cats, dogs, and rabbits. A confusion matrix for this would look like this. So since here we have more than two classes, we cannot talk about true negative or false positive or false negative or false positive. For example, here we have the actual values are in the columns, as you see here, cats, dogs, and rabbits. And then we have the predictions of these animals on the column. For example, we have 5 cats have been truly predicted as cats, and 2 cats have been predicted as a dog. No cat has been predicted as rabbits. 3 dogs have been predicted as a cat, and 3 dogs have been predicted correctly as a dog, and 2 of the dogs have been corrected as rabbits here. Also for rabbits, we have 0 rabbits have been classified as cat, 1 rabbit have been classified as dog, and 11 rabbits have been correctly classified as rabbits. So this confusion matrix is going to give us more than just the accuracy score. It's going to also tell us which animal has been correctly or incorrectly classified, and if it's incorrectly classified, which animal has been classified to. For example, the cats have been classified to dog or rabbits. Both of them are incorrect, but they are different still. So using confusion matrix is much informative and much helpful than just an accuracy score here. If we wanted to only suffice with the accuracy score, that would be 5 cats and plus 3 dogs and 11 rabbits. These are the only animals out of the 27 that have been correctly classified. So our accuracy score would not be really such informative. Compared to this one that we know, okay, we have 2 cats that have been classified as dog. We have 3 dogs classified as cats. We have 2 dogs classified as rabbits, and so on and so forth. So a confusion matrix is much more informative than the just accuracy score. Let's see an example of confusion matrix for a binary classification problem. Suppose we have a binary classification problem in which we want to classify our emails as either legitimate emails or spams. So we have 2 classes, spams and legitimate. We're going to call the spam class as the positive class, +1, and the legitimate email as the negative class, or class 0, negative. So again, spam is positive and legitimate is negative class. Our data set, on the other hand, is biased, is imbalanced. So that means that we have 450 emails total, 15 of which only are spams or the positive class. 430 of them, which a big bulk of them, are the legitimate or the negative class. So the majority of our data is the legitimate or the negative class. We have developed a classifier here, as you see here. This is the line of the classifier. So anything below this line, based on feature 1 and feature 2, so the x-axis shows the feature 1 and the y-axis shows the feature 2. So you can see that these are going to, feature 1 and feature 2 is going to be the coordination of these data points here. And we have 450 circles here. Some of them are red, solid, and some of them are white and empty, as you see here. The white or empty ones are legitimate or class negative, and the solid or the red ones here, these are spams or positive class. So based on this figure, you can actually see whether we have made a correct prediction or not. And also more about that, actually, you can see you can actually build the confusion metrics here. For example, these data points here, its true color or label is actually positive. It means that it's a spam because it's solid, it's red. But because it's actually under this line, it has been classified as negative or legitimate email. So this is a wrong and incorrect prediction. It's a false prediction. So that's why it's false negative. It has been classified as negative, but it's truly positive. So that is false negative. Also this point right here as well. So we have two false positive here. On the other hand, we have all of these data points right here. These are negative. The true label or color, these are legitimate emails that have also been classified correctly as legitimate. So these are true negative, as you see here. All of these are true negative. The data points above these lines are classified as positive or spams. So as you see here, we have some mistake here. For example, these data points right here, its true label, because it's empty, is white circle. Its true color actually is white. So it's actually a legitimate email, its actual label. But because it's above this line, it has been classified as positive. So it's a false positive. There are more false positive here. This is false positive, this is false positive, and this is also false positive, and this is false positive. On the other hand, we have some data points, some spam that has been correctly labeled as a spam here. So for example, this one, and all of these. So these are true positive. All right, so based on this output, we can actually build the confusion matrix. You are familiar with confusion matrix, is the true positive, true negative, etc., etc. So here, as you see here, on the row, we have the actual labels. So legitimate, that means that it's negative, and a spam, that means it's positive or true. And then on the column, we have our prediction. The first column is classified as legitimate. That means that it's we have classified as negative. And the second class is a spam. So that means that we have classified as positive. So now we can build the matrix, the confusion matrix. How many true negative do we have here? So the true negatives are those legitimate emails that have been classified as legitimate. So The output is 429 based on our output of the model that you don't see here, but it's easy to actually build it through Scikit-Learn. And also we have 6 false positive. As you look here, we have these are false positive, this is false positive, false positive, false positive, and false positive. So we have 6 false positive here. On the other hand, we have 2 false negative. So this is false negative because it's actually a spam, but it has been classified as a legitimate email here. So one is here and the other one is also here. So 2. False negative is 2. The next is true positive. So these are true positive here. If you count these solid circles, red circles above these lines, these are true positive, which there are 13. Having these confusion metrics, now we can actually find the accuracy score. So the accuracy score is the number of the percentage of correct prediction, or the number of correct prediction versus the total number of prediction. So we have 429 true negative and 13 true positive. So these are our total correct predictions out of the 450 predictions that we have here. So we can find the accuracy score here. The accuracy score is about 98%. We can actually use Scikit-Learn to build the confusion matrix. You don't have to actually count as we did it here, the circle. This was just for demonstration.